It's lesson 85, applying properties of rational numbers and irrational numbers. So today we're going to use, we're talking about conceptual ideas about the properties and how we can use them to our advantage. You've kind of talked about this before. You've talked about properties in middle school and pre-algebra. But today we're going to just kind of revisit that because it's important to use math to your advantage, to use it strategically, right? Sometimes you have a process, and sometimes it's easier to do something than to do many things. For example, let's say I had a big pile of oranges here, and I had a basket, and I wanted to move it to the opposite side of the room. Couldn't I just pick up one orange at a time? Put it down, go back, get the next orange. Let's say I had 30 oranges. Down. Couldn't I do that? Okay. What's wrong with that situation though?
It takes longer.
Takes longer. But at the end of it all, wouldn't I still get over to the end and get all the oranges and the basket over there? What would be the easier thing to do? Start off by putting them all in the basket, right? Take the basket, walk over there, put them down. Does that make sense? Yeah? Okay, so the same thing with math. Sometimes we don't really plan ahead when we're doing the math problem. We're like, oh, we don't see the patterns and we don't use the properties to our advantage. Okay? So, here are the steps for today. Use PEMDAS, of course, when you're evaluating expressions. If you identify a property, use the property to your advantage. Okay, so the commutative property is really important, and the associative property today. And then there's irrational numbers. We're going to talk about that a little bit more tomorrow. But irrational numbers, just treat them like terms, right? Pi is an irrational number. We use just pi as pi, right? So we don't write the whole thing out 3.14 or whatever it is, right? Okay, so number 1, okay? Negative 4/7 times 2/5. Okay, what I could do here, we have two separate terms. We have this one and this one, okay? Oh, one more thing before I go back. Sorry, I want to go back. I want to explain one more thing. Commutative property, I want you to underline the word commute on your notes and write moving numbers, okay? Just like when you commute to school, you are moving your body to school, right? Commuting to school. Associative, underline associate. This means grouping numbers, okay? Can you write that down in your notes so that you have those? Okay, so the two things, commuting is moving numbers, and the second one, associated, is grouping numbers. Okay, so number 1, we got negative 4/7 times 2/5. Now, this might seem a little bit overwhelming for some students, but what you could do is use the commutative property and move it all together, so it could be negative 4 times 2 in the numerator over 7 times 5. And what I just did is I used the commutative property of multiplication specifically. And I'm going to work this out. Negative 4 times 2 is negative 8. And then 7 times 5 is 35. Okay? So, for some students, it's a little bit easier to think that way. Now, could you have done this one in your head on number 1? Yes or no? Yeah, you can totally do it in your head. So, but I used the commutative property to work my problem out in chunks. Okay? Does that make sense? So that's on number 1. Look at number 2. We have 1/2 times 2/3, all times 6. Wow. That looks kind of hard, right? If you notice here, these two fractions on the left are grouped together, right? But thankfully, we have the associative property of multiplication here. 1/2 times 2/3 is kind of a hard problem to deal with. So I want to move some things around before I start working this problem. The first thing I'm going to do is I'm going to use the commutative property, and I'm going to write 2/3 times 1/2. I'm going to switch these two around. So the first thing I did is I switched the two fractions around and kept the 6 there. Okay? And I just used the commutative property. of multiplication. And now I'm going to switch the grouping. Watch what I'm going to do. I'm going to move these parentheses. I'm going to keep the 2/3 times the 1/2 times 6. But this time, instead of putting my parentheses in the same place, watch what I'm going to do. I'm going to move them. Because I know that 1/2 times 6 is an easy problem. What's 1/2 times 6? What's 1/2 of 6? 3, right? So I could easily know that this is 3. So what I just did is I used the associative property. Okay, and we have 2/3 here multiplying, and of course 2/3 times 3 can make this over 1. 3's cancel out, or we could do what we did on number 1, just put 2 times 3 all over 3 times 1. 2 times 3 is 6 over 3. 6 over 3 is equal to 2. Okay? So what I'm doing is I'm using the properties to my advantage. I was able to, instead of doing a harder fraction problem, I just went straight to moving the numbers on because I know 1/2 times 6 is 3. Did y'all see that? Okay, so today is really more of a conceptual day. You already know how to multiply. You already know how to add, subtract, multiply, and divide. I already know that. You should already know these properties. They've been taught to you since middle school. But I want you to intentionally use the properties to solve the problems, okay? To your advantage. Does that make sense? Okay, so let's have, today is Tuesday. Let's have two other ones about number 1. Number 3. 5/16 times 3/11. Let's think about number 1. What property should I use to solve this one? Commutative property, right? So we could just rewrite it as 5 times 3. So you're doing this one together with me, by the way. All over 16 times 11. Okay. 5 times 3 is 15. Good. 16 times 11 is... Oh, you could do a side problem. It's okay. 176. Okay, can't simplify that, so we're all done. Any questions on number 1? Now do number 2 for me. Ready? Set, go. Times 6 11 could be 7 times 6 over 8 times 11, right? Makes it easier to see that. 7 times 6 is 42. 8 times 11 is 88. What goes into both of these? Well, it's even, so at least 2 does. What's 42 divided by 2? 21. And 88 divided by 2 is 44. That's number 4. Make sense? Yeah? Okay, continuing. Number 4. Okay, number 4 looks kind of scary, right? We got this 4 times 27 divided by 1/25, okay? So, it's a division problem in here. Usually you can multiply. We could do 4 times 27, right? But isn't that a hard number to deal with, right? So, I'm going to work out my division problem first. I'm going to show you what I'm going to do. So, whenever I divide fractions, I'm really multiplying by the reciprocal, right? 25 over 1. And 25 over 1 is just 25, right? Okay. Raise your hand if you see any key numbers you can multiply together before we move on. What 2 numbers should... Any strategies? Yeah. Which is? 100. Good. Couldn't we do 4 times 25? Right? So we're going to use, just like we did on numbers 1 and 2, we're going to use the commutative property to rewrite this 4 times 25 times 27. And while we're at it, we're going to use the associative property to regroup these, right? Because we know that 4 times 25 is 100. And then 100 times 27 is? What's 27 times 1? 27, then add 2 zeros, however many zeros. 2700. You see that? Again. How did I get that? 27 times 1 is 27 with the 2 zeros right here. Make sense? Okay. Now I want you to do the same thing on number 6. It's a little bit harder. Similar process. Ready, set, go. So this one, again, we're going to multiplied by the reciprocal. So we got times 31 times the quantity of the reciprocal, 15 over 1. Since it's already over 1, why don't we just take the over 1 out, right? What are two key numbers you can multiply together? 15, 6 and 15, right? What's 6 times 15? 90, right? So 10s are good to memorize, 5s of course, and 15s are good to memorize, and 25s. Move the 31 over, so we said this is equal to 90, and then we have to do 90 times 31, okay? Now there isn't any shortcut here, but you can just go 31 times 9. Look at my little shortcut I'm going to give you. 31 times 9 is, well, we're good. 9 times 1 is 9, 9 times 3 is 279, and then we have a 0 after that. So the answer is 2,790. Does that make sense? Some of you put some 1800 something. I'm not sure where that came from. Okay. There are a few of you actually, not just one of you. Okay. Now I could give you infinite examples. I could give you a ton of examples of how to do this, but you need to start looking at the opportunities to change your problem up a little bit, because you are in control of it, right? Do you want to work harder or smarter? Which one do you want, harder or smarter? Smarter, right? Because you want your life to be efficient, okay? Just like you would, if I had a big pile of oranges here, I wouldn't take them one by one back and forth. I would put it into a basket, okay? That concludes this lesson.